Bismillahirrahmanirrahim. Welcome to Applied Thermodynamics by McConkey with Dr. Abid Hussain. So, in this lecture, we solve problem 1.5, and for more problems, please like and subscribe my YouTube channel. So, problem is a fluid at 0.7 bar occupying 0.09 meter cube is compressed reversibly to a pressure of 3.5 bar according to a law PV power n is equal to constant. This is first process, and first process is according to PV power n is equal to constant, and P1 and P2 are given. P1 is 0.7 bar and P2 is 3.5 bar. Similarly, V1 is given to us total volume 0.09 cubic meter. Second process is then the fluid is then heated reversibly at constant volume until the pressure is 4 bar. Second process is heating at constant volume, and at heating at constant volume pressure increase from 3.5 bar to 4 bar. The specific volume is then 0.5 meter cube per kg. Here specific volume is given. A reversible expansion according to a law. Third process is according to PV square is equal to constant. Restore the fluid to its initial state. Restore the fluid to its initial state means that the cycle is completed at third process. Sketch the cycle on PV diagram and calculate mass of fluid. Calculate M, value of N in the first process, and the net work of the cycle. First we write data for the first three processes. So in first process is according to PV power n is equal to C. First process is according to PV power n is equal to C. P1 is given as 0.7 bar and V1 is equal to 0.09 cubic meter. Similarly, P2 is equal to 3.5 bar and V2 is not given. Second process is constant volume process, heating at constant volume, and this process pressure is increased from 3.5 bar to 4 bar, and specific volume is given. Specific volume is given. V3 is equal to 0.5 meter cube per kg, and third process is according to PV square is equal to constant, and this process all the data is restored to initial. So in third process P1 is equal to 0.7 bar, cycle is completed in third process, and V1 is equal to 0.09 meter cube per kg, 0.09 meter cube total volume. So here V1, V2 and V3, this is constant volume process. It means that V2 is equal to V3, or total, this is specific volume, or total volume is equal to V2 is equal to V3. So we can find easily V2 and V3. Okay, and required data number 1, mass of the fluid. Number second, N, find N from first process, and number third, find net work done for the cycle. So first sketch the PV diagram. For this we find total volume. So from third process is according to PV square is equal to C. So this implies that P1 V1 square is equal to, this is for third process, P3 V3 square. So from this we found V3. So V3 square is equal to P1 V1 square divided by P3. P1 is equal to 0.7 bar multiplied by V1 is equal to 0.09 meter cube whole square divided by P3 is equal to 3.5 bar. So So V3 square, if we simplify this, so V3 square will be equal to 0.0014175, 0.0014175 meter power 6. This is V3 square, so take under root on both sides. So V3 will be equal to 0.0376 meter cube total volume. Now we can draw PV diagram. So P1 is 0.7 bar. This is P1 and V1 is 0.09 cubic meter. V1 is equal to 0.09 cubic meter. This is pressure in bar, and on x-axis volume in cubic meter. So first one is this. So this is first one. Second one, pressure is increased to 3.5 bar and volume is decreased to a second process is constant, so V2 is equal to V3. This also V2. V2 is equal to V3, 0.0376 meter. This will be equal to 0. This is V2 is equal to V3 is equal to 0.0376 cubic meter. So this will be the second one. This will be the second one. And this process is PVN is equal to C. So draw curve from 1 to 2. PV power N is equal to C. Now second process is heating at constant volume up to pressure 4 bar and volume is constant. So this is second process, straight vertical line from 2 to 3, and at this process V is equal to constant. And third process is restore to initial according to LR, PV square is equal to constant. This will be curve PV square is equal to C. This is the PV sketch for this cycle. Now first required is mass. First one to find mass. So total volume 8.3 is 0.0376 cubic meter and specific volume 8.3 is 0.5 meter cube per kg are known. So from these values we find mass, as we know that specific volume is equal to total volume divided by mass. So rearrange this equation, mass is equal to total volume divided by specific volume. Total volume is 0.0376 cubic meter and specific volume is 0.5 meter cube per kg. So M is equal to 0.0752 kg. This is specific volume. Now second requirement to find N. To find N from the first process. From the first process we know that PVN is equal to C. So this implies that P1 V1 power N is equal to P2 V2 power N. So rearrange this equation. V1 power N divided by V2 power N is equal to P2 divided by P1. Yeah, so this implies that V1 divided by V2 power N is equal to P2 divided by P1. Now putting values, V1 is 0.09 cubic meter and the value of V2 is 0.0376 because V2 is equal to V2, constant volume process, whole power n is equal to, the value of V1 is 3.5 bar, sorry, P2 is 3.5 bar, the value of P2, and the value of P1 is 0.7 bar. Now simplifies, 0.09 divided by 0.036 is equal to 2.3936 whole power n is equal to 5. Now to find n, take natural log on both sides. Natural log of 2.3936 whole power n is equal to natural log of 5. So according to log law, n will be in the coefficient. n natural log of, and find directly natural log of 2.3936, which is equal to 0.8728, and natural log of 5 is equal to 1.6094. So n is equal to 1.844. So now the third requirement is to find net work. For net work, first we find work done from 1 to 2. For this process is according to PV power n is equal to C. So first we find C. As PV power n is equal to C, so P1 V1 power n is equal to C. Putting values, so this implies that C is equal to, the value of P1 is 0.7 bar, 1 bar equal to 10 power 5 Newton per square meter, and the value of V1 is 0.09 meter cube power 1.844. Simplify this, so the value of C will be equal to 825.50, and there will be some unit. Now work done from 1 to 2, formula is minus integral of 1 to 2 P dV, which is equal to minus integral of V1, lower limit is V1, upper limit is V2, and from this equation we can write that P is equal to C divided by Vn. So put here C divided by V power n dV. So W from 1 to 2 is equal to, C is constant, and V1 to V2, V power n in numerator is equal to V power minus n dV, which is equal to minus C, and take integration, so V power minus n plus 1 divided by minus n plus 1. Lower limit is V1 and upper limit is V2. So W from 1 to 2 is equal to minus C, the value of C is 825.50 unit, and V power minus 1.844 plus 1 divided by minus 1.844 plus 1. Lower limit is V1, upper limit is V2. So W from 1 to 2 is equal to minus 825.50 divided by minus 1.844 plus 1 is equal to minus 0.844 plus 1, and this will be equal to V power 0.844, and denominator this will be plus V power 0.844. Lower limit is V1 and upper limit is V2. So W is equal to, W from 1 to 2, minus will be cancelled with minus, and this is equal to 978.08, and apply limits, 1 over V2 power 0.844 minus 1 over V1 power 0.844. So W from 1 to 2 is equal to 978.08, 1 over value of V2 is 0.036 376 power 0.844 minus value of V1 is 0.09 power 0.844. So W from 1 to 2. Simplify these values. So final answer will be 8133.71. This is simple calculation. You can do this. Now work done from 2 to 3. Work done from 2 to 3 will be equal to 0 because volume is constant, and in constant volume work done will always be 0. There will be no work done in constant volume process. And now for work done from 3 to 1, first we find C. Third process is according to PV square is equal to C. So P1 V1 square is equal to C. Putting values, so C is equal to value of, and third process P2 V2 or P3 V3 square. Because this is third process. So value of P3 is 4 bar, 4 multiplied by 10 power 5 Newton per square meter, and value of V3 is 0.0376 square. So C is equal to, similarly we can, this third process we can also find this from first process plus P1 V1 square. So 0 pressure is 0.7 and V1 is 0.0. We can find this from both P1 V1 square because this is PV square and third process, so P3 V3 square is equal to P1 V1 square. We can find C from P1 V1 square and also from P3 V3 square. So the value of C is, if we simplify this, this will be equal to 567 Newton meter power 4. Now work done from 3 to 1 is equal to minus integral of 3 to 1 PdV. As PV square is equal to C, so P is equal to C divided by V square. So put here lower limit V3, upper limit V3, and put here P is equal to C divided by V square dV. So W from 3 to 1 is equal to, C is constant, so minus C, and 1 over V2 is equal to V power minus 2 V3 to V1 dV, which is equal to minus C. Take integration, minus 2 plus 1 divided by minus 2 plus 1. Lower limit is V1, upper limit is V2. So W from 3 to 1 is equal to minus C V power minus 1 divided by minus 1, and lower limit is V1, upper limit is V2. So W from 3 to 1 is equal to minus C divided by minus 1 is equal to C, and V power minus 1 is equal to 1 over V, and applied limit 1 over, this is V3, this is V1, this is V3, and this is V1, this is 1. So 1 over V1 upper limit minus lower limit 1 over V3. Now putting values, W from 3 to 1 is equal to, the value of C is 567 Newton meter power 4, and the value of V1 is 0.09 cubic meter minus 1 over 0.0376 cubic meter. Now simplify these values. This is so simple, and find the value of W from 3 to 1. Final value is a minus 8780.41 Newton meter. Now find the net work done. So net work is equal to work done from 1 to 2 plus work done from 2 to 3 plus work done from 3 to 1. So net work done will be equal to W1, net work done will be equal to, work done from 1 to 2 is 8133.71 Newton meter, work done from 2 to 3 is 0 Newton meter, and from 3 to 1 is 87, this is minus This is minus. This work done is minus 8.41 Newton meter. So simplify this. So net work done will be equal to minus 646.7 Newton meter. Negative sign mean that net work done by the system is equal to 646.7 Newton meter. So this is the final answer, and for more videos please subscribe my YouTube channel. Thank you.